Lesson 11 is on constant rate. Now, yesterday we took a critical look at proportional relationships, and we were talking about the constant. Again, finding that constant of proportionality, and we really did a lot with the speed, which is distance divided by time. Sorry, it took me a second to remember that, but I want us to still focus on that. Okay, so when we're talking about the rate of something, I'm going to think of it in terms of our average speed. Okay. And it may be not traditional speed, but we're really thinking how fast, how many gallons per hour or, miles per minute or whatever it is. And we're going to find that constant rate, that average speed, again using RC, which is distance divided by time. And this constant, guys, when we think of it in terms of like the seventh grade way of thinking, that is still our constant of proportionality. It's the number we're multiplying by. There, getting to the end of it. Okay, so that we're looking for what we're multiplying by as time goes on. So in example 1 here, when it says Pauline mows the lawn at a constant rate, and then it gives us some information about that. She mows a 35 square foot lawn in 2.5 minutes. Now, this is not our traditional distance divided by time, but we still have the time. Okay, so it's not like a distance maybe measure, but now our dependent variable is how much lawn can she mow in a given amount of time. So, because what area in square feet can she mow in 10 minutes, in T minutes? And that is the power of this statement right here. Write the equation first. And spell it correctly. Write the equation first. All right, because we want to know how much can she mow in 10 minutes? How can she mow in T minutes? If we have the equation, then we can figure out how much lawn she can mow in a given amount of time. So remember, we have our 7th grade way and our 8th grade way of doing it. I don't really care what you need to, but I'm going to start just referring to our 8th grade way of doing it. But for now, I'll remind you. Remember, in 7th grade, we found a constant proportionality. We took our dependent variable y and divided it by our independent variable x. Now we're thinking of it, and I'm going to use distance, but distance divided by time. Either way we look at this, we have 3.5 square feet over 2.5 minutes. And maybe you don't, we can't figure out what the distance is, but we can figure out the time. So the other one has to be distance. So if I divide 3.5 by 2.5, it works out to be 1.4. Except I realized, again, I'm on a roll lately. This is not 3.5. How about it's 35? Let's try that again. Let's go 35 divided by 2.5. Hope I'm right this time. That looks better. 14. So our constant is 14. Now remember, I said we have to write this equation first, right? Well, we write an equation. We have our generic form of y equals kx. So we basically can take our constant, our k, and plug it in. And we get y equals, not k. What is k? 14 times x. All right. Now, if we look down here, if we just kind of cheat a little bit, we can see this, remember, is our x column. This is our y column. And we're not going to use x, we're going to use t. But we're still going to use y here. So I'm going to still leave it as y equals 14. Instead of saying times x, I'm going to say times t. Okay, so that is our 7th grade way of doing it. Our 8th grade way, still writing the equation first, is we set up our proportions. So we have 35 square feet over 2.5 minutes. And I'm just going to set it up to y square feet over x minutes. And then we use the cross products. So I'm going to go 2.5 times y and 35 times x. Could have made it a t, but I'll do that at the end. always solve for y. So I'm going to divide both sides by 2.5. And we get y equals 35 divided by 2.5. And when you type that correctly into a calculator with the right numbers, you get 14x. Again, we're going to replace x with t. So either way we do it, we get the same answer. Okay, so this is the way I'm going to kind of start referring to, but we get the same answer either way. All right, so now we want to find out how much you can mow in 10 minutes and t minutes. So we have a couple different ways of doing it. This equation represents it, but we also can make a table. And we have a graph here, so we're going to focus on these two ways. So our equation is 14 times t. We don't have any t's. But in this case, it doesn't make sense for us to use negative numbers. So you get to pick these. So let's say I pick 0 minutes. Well, if I plug 0 in for t right here, I'm going to go 14 times 0, and I'm going to get 0. What if it was after 1 minute? Well, I'm going to go 14 times 1, and she can mow 14 square feet in 1 minute. How about a 2? 14 times 2, and that's 28 square feet. And we could keep going. Let's say I jump to 5, because we can pick whatever we want here. 14 times 5 is 70 square feet. The original question wanted to know how much can she mow in 10 minutes? Well, if I put a 10 in here, I can go 14 times 10, and I'd get 140 square feet. She also wanted to know t minutes. Well, in t minutes, she's just going 14 times t. That's really what our equation is. So now I can represent this data on a graph, and this is just by plotting these points. Remember, this right here is the point 0, 0. This is 114. This is 228, and so on. So 0, 0, this is why it's proportional, because it goes to the origin. 114, we can approximate it. 228. 5, if I jump to 5. 70, that's off the graph. But I would expect it to be kind of up here, right? So it should still line up as a line. And that's why we have the line. Okay? Because then the line's going to represent all of those that we didn't pick, but someone else might have. Okay? So this should look pretty familiar. We're just looking at it just with kind of fresh eyes and talking about it a little bit differently. Okay, but these are all different ways to represent the same information. How much lawn can she mow in a certain number of time? Let's look real quick at one more example. Water flows at a constant rate. So again, there's that constant rate. We're thinking proportional relationship. This case, we're talking about the volume of water that comes out in 3 minutes. So there's my time, is 10.5 gallons. Now that's going to be my D, not really D. You can see here we have T for time, and they're going to use V for gallons. I don't know why V, but that's what I'm saying. You might not know what that D is up top, that constant rate, but we want to know per time always. So if I want to know how much comes out in T minutes, I'm going to say my constant rate, in this case, is V divided by T. And what do I have here? 10.5 gallons in 3 minutes. Now set that equal to V over T. Again, gallons per minute. Right? Always line it up. And then you can use cross products. Now, I always said to solve for y, but you're going to notice in this case, the way I set it up, we don't have a y. Always solve for the thing that's not time, because times are independent variable. So whatever else is going to depend on that time. So I'm going to go 10.5 times t. I am going to divide both sides by 3. I am going to hopefully, draw a random line on my paper. Hopefully get it right this time. 3.5, that seems right. And this is going to work out to be 3.5 times t. So that's going to be our equation. 3.5 times t. Once we get that equation, and remember, we're going to do the equation first, then we can gather information after that. Now, how much gallons of water come out in T minutes? Well, whatever 3.5 times the number of minutes. So in 0, we go 3.5 times 0, which is 0. If the time is 1 minute, I'm going to go 3.5 times 1 and get 3.5. If it's 2 minutes, I'll go 3.5 times 2 and get 7 gallons. 3.5 times 3 and get 10.5, which we already knew. 10.5 gallons, I could go 3.5 times 4. If I multiply those together, I get 14. And so another way to represent this equation right here is we can do it as a table. We can also do it as a graph. So if I want to plot these points, there's 0, 0. 1, 3.5, it's going to be halfway between the 3 and the 4. 2, 7. And I'm anticipating, because this is proportional, that they're going to lie on a line. And in this case, we are given the x values, but we draw a line so it represents all the possible values. And my line's not the best. I think I can move it. Let's see. I can. Kind of. Because other things pop up. All right, so again, we're just taking a look now at constant rate. Yesterday was a critical look at proportional relationships. We remember what proportional relationships are. Now we're really focusing in on this rate and writing an equation from it.